Before going to the exercise 4.4, that is related to the integration of some functions, before starting that exercise, we need another concept to solve that integration. That is partial fractions. That partial fractions is also explained in the first year maths course, but here this partial fraction is needed for the integration of the complicated functions that have the denominator more complicated as before we were having the integration questions. For example, partial fractions. In partial fractions, basically we just split our one fraction into many fractions, and that can be easily integrated as compared to the complicated fraction. For that purpose, we have some rules to apply the partial fraction, to just start applying the partial fraction. For example, if we have a fraction x minus 1 into x plus 1, if we have a fraction, if we have this fraction to integrate, we will just first have the partial fraction of this fraction and then we will use it to integrate. For that purpose, we must know how to find the partial fractions out of this one fraction. For that purpose, we will split our denominator like this. It is already factorized form. First of all, if you have the denominator in this form, for example x squared plus 2x plus 1, you need to factorize it. After factorization, now you got the simplest brackets, functions in these brackets. You see, these have the power 1 now. It will be split as a over x minus 1 plus b over x plus 1. Separately it is written. Just forget this numerator and just use these denominators one by one and write the capital alphabet A and write the capital alphabet B like this. We will explain the whole process that is used in the partial fraction in the questions of the integration. I'm just here explaining you that how we are splitting it into the fractions. For example, if I have 2x plus 1 divided by x minus 1 whole cube into x plus 2. Now you see it is in the factorized form. It can be written as x minus 1 into x minus 1 into x minus 1. It is the simplest form. The partial fractions of this fraction will be a over x minus 1 plus. Now if we have some simplest function here with some power, whole power, it will be written as, first of all with the power 1, then b over x minus 1 power 2 plus c over x minus 1 power 3. If we had 4 here, then we will move on to d, but we have cube, so just stop here at c. Now this denominator is left here, so it will be d over x plus 2 now. For example, if we take another example of a fraction, let's suppose we have, you just have to forget this numerator. There's no use of it. It will be just used in the other steps when it is applied in the questions. For example, you have 3 over x squared plus 1 into x minus 1. After factorization, for example, if you got these two brackets, you see this is the simplified form. This is not the simplified form. It has the power 2. It will be written as, just write the simplest one first, a over x minus 1 plus, due to this x square, you will write here bx plus c over x square plus 1 like this. This is another form of the partial fraction. For example, you have x square plus 2x plus 1 over x square plus 4x plus 3. You see here the highest power is same. So first, this is an improper fraction. So first of all, you will convert it into the proper fraction by dividing it. After dividing, you will get some answer, and then you need to just factorize your denominator. Then after the factorization, you will just break it into the partial fractions. So here are some of the methods. You can just split your one fraction into the partial fractions like this. So let's start the exercise 4.4. Exercise 4.4, question number 1. We have to integrate x over x minus 1, x minus 2. Now you see our denominator is in the factorized form. We can easily find out its partial fractions, and they are the simplest forms. It can be written as a over x minus 1 plus b over x minus 2. Now we have to make it a straight line equation. Just multiply both sides. Multiply both sides with this whole denominator. If I multiply both sides with this denominator like this, then this thing will be cancelled with this with this, and x minus 2 with x minus 2, and I will get x equals x minus 2 into a plus x minus 1 into b like this. Name it as the first equation and name it as the second one. Now we need to find out these constants a and b. So the whole method is basically for finding this a and b, and then we will just substitute back the a and b and we will integrate the both sides, and then we will get the integrated answer. For that purpose, this is the simplified your bracket like this one. Your denominator was x minus 1 and x minus 2. Consider your denominator, take the one bracket and let it equals to 0. For example, I have taken first x minus 2 equals to 0. Now from this I will get x equals to 2. So just put x is equals to 2 into equation 2. I will get in place of x 2. 2 minus 2 will be 0. At 2 minus 1, here I will have 1. Simplifying both sides, I will get b equals to 2. Now I have considered this one. Now let x minus 1 equals to 0. So I get x is equals to 1. So put it in equation number 2. After putting x is equals to 1 in equation number 2, here I will get 1. 1 minus 2 will be minus 1a, and 1 minus 1 will be 0. So I got 0 here. So a is equals to minus 1. Now use these values of a and b in equation number 1. I will get x over x minus 1, x minus 2 equals to, in place of a I have written minus 1, and in place of b I have written 2. Now this is the complete partial fraction form, simplified one. So integrating both sides, just apply the integration on both sides. I will get minus integral 1 over x minus 1 dx plus this 2 is a constant, it has taken outside, integration of 1 over x minus 2 dx. This is the integration will give ln x minus 1, and 1 over x minus 2 have the integration x ln x minus 2. You see, this ln or the log have the property that the coefficient could be the power of this function. So I have written as ln x minus 2 whole square and minus ln x minus 1 as it is. Now using the property of log, natural log, that this has the positive power, so it will be considered as the numerator. This is the negative one, so write it in the denominator and with one ln, with one log. So ln x minus 2 whole square and over x minus 1 plus C is the answer of question number 1. Question number 2. Integrate 2x minus 3 over x square minus 1 2x plus 3. For that purpose, we need to factorize our denominator. This will be factorized as x minus 1 into x plus 1, and the third one is already simplified, it will be written as it is. Now split it, a over x minus 1 plus b over x plus 1 plus c over 2x plus 3. Multiplying both sides with this whole thing, we will get this thing, whole denominator will be cancelled with this whole thing. We get 2x minus 3, a into x plus 1, 2x plus 3 plus b into x minus 1, 2x plus 3 plus c into x minus 1, x plus 1. That is equation number 2. Now let one by one these brackets equals to 0. So let x plus 1 equals to 0. That will give x equals to minus 1 and put it in equation number 2. Now our x plus 1 is 0. So just make the x plus 1 whole thing equals to 0. So I will get only this b term and replace x with minus 1. I will get b, minus 1 will be minus 2, and 2 into minus 1, minus 2 plus 3 will have 1 here. So after simplification, I will get b is equals to 5 by 2 here. Now let x minus 1 equals to 0. So x is equals to 1. Put it in equation number 2, and after simplification I will get a equals to minus 1 over 10 here. Now the third one, let 2x plus 3 equals to 0. So I will get x is equals to minus 3 by 2. Put it in equation number 2. Now 2x plus 3 is equals to 0. Just make the terms having 2x plus 3 in coefficient equals to 0. So I will left with only c term. So I will get, after simplification, c equals to minus 24 over 5. Just replace a, b and c in this equation number 1. I will get, in place of a, minus 1 over 10, in place of b, b value, and in place of c, c value. Now integrating both sides. After applying the integration on both sides and take the constant coefficients outside, I will get this thing. Now x minus 1 have the differentiation 1 that is present here in the numerator. So it will have the integration ln x minus 1. Also same case will be here, ln x plus 1. Now if I take the derivative of 2x plus 3, its derivative will be 2. So if I make 2 here, it can be easily integrated as ln x 2x plus 3. So I have made 2 here by multiplying it with 2 and dividing it with 2 as well. So this will be simplified as 12 over 5, and this thing will give us ln 2x plus 3. We can leave our answer here, or we can further simplify it as this coefficient could be made as power, like ln x minus 1 power 1 by 10. This coefficient will be its power, ln x plus 1 5 by 2, and this coefficient will be its 12 by 5, will become its power. Now the positive terms will be numerator and the negative terms will be written in the denominator and with one natural log function plus c. Question number 3. X plus 1 over x square plus 4x plus 5. This can also be solved using the partial fraction method, but if you avoid the partial fraction method, you can easily solve this question without applying the partial fraction method. If you have any method other than the partial fraction method, then just apply that, because the partial fraction method will be the lengthy method and you will get enough time to solve it in your exams. So just use the other method if it is in your mind. Otherwise, you have no choice to apply the partial fraction only. I am just making you see here, I need 2x. If I make its derivative in the numerator, I need 2 here. So just multiply the numerator with 2 and divide it with 2. Now if I take its derivative, I need 2x plus 4. So I can write in place of 2 as plus 4 minus 2. When I get back, solve it, I will get back this 2. So I just split it into 2 parts, into integration, and I will get 2x plus 4 divided by this denominator minus 2, this minus 2 x square plus 4x plus 5, and this coefficient is written as it is with both the integral signs. Now this denominator has the differentiation derivative in its numerator, so it will be ln x square plus 4x plus 5. Now this thing can be written as by completing square method like this. We know that x square plus 4x plus 5. If we complete its square, this is x square plus 2 into x. Now I need something here to make it 4x. To make it 4x, I will write here 2. So I need here 2 whole square. So I will just subtract 2 whole square as well and plus 5 as it is. First 3 things will make x plus 2 whole square. Last thing will be minus 4 plus 5. That can be written as x plus 2 whole square plus 1. Now it can be written as x plus 2 whole square plus 1 whole square. So this is the integration formula of x square plus a square. That is 1 over a tangent inverse x over a. So I have written 1 over a tangent inverse x over a. This is whole x and this is a, like this. So I got this answer of question number 3. Question number 4. Integrate 2x square plus 3x plus 1 divided by x square plus 2x plus 2. Now, I know that this is an improper fraction because both have the same power. So just divide it. And how you are going to divide it, I already told you many times in some other questions of the integration that what is the method of division. Denominator will be written outside like this and the numerator will be written inside like this. Now consider the highest power first element and divide it with the highest power of the outer one. So after cancellation we got 2. So just write 2 here and multiply 2 with this whole thing. I will get 2x square plus 4x plus 4. Subtract it by changing the signs. It will be cancelled. I will get minus x minus 3 like this. So the method of writing it is, it will be written as 2 minus, it can be written as, if I take minus sign common, x plus 3 divided by this thing, x square plus 2x plus 2. So I have directly written it here. Now this integration can be split into two parts like this. Now I can make x square, if you consider x square and take its derivative, it will be 2x. So I am just making 2 here by multiplying this whole thing with 2 and dividing it with 2. So I got 1 by 2, 2x plus 6. Now consider this whole thing and take its derivative. Its derivative is 2x plus 2. So I can make here 2 by writing it as 2 plus 4. Now consider this one as a separate and this one as a separate function. Just split it into two parts like this. After splitting it into the two parts, you see the numerator is the derivative of this denominator. So it can be written as ln this denominator. Right? Now this 4 will be taken outside, and after taking it outside, I will get 4 divided by 2 as 2. Now I can complete its square by the same previous method. Like in question number 3, we have x square plus 2x plus 2 here. It can be written as x square plus 2 into x. Now I need to write here some number so that I can get back this 2x. So I will write here 1. So I need plus 1 square and minus 1 square as well, and plus 2 as it is. The first three things will make x plus 1 whole square, and the last two things will make plus 1. So it can be written as x plus 1 whole square plus 1 whole square. And you know that this is the formula for integration of 1 over x square plus a square. So use this formula, tangent inverse x over a, 1 over a as well, and just simplify it. We will get this answer of question number 4. Question number 5. In question number 5, we have to integrate x square over x minus 1 whole cube into x plus 1. It can be split as a over x plus 1 with 1 power. Then, okay, I have written this one as first, but it's up to you. You can write any one as the first fraction. So a over x plus 1, then b over x minus 1 with power 1, c over x minus 1 with power 2, and d over x minus 1 with power 3. Now multiply both sides with this whole denominator, and after cancelling the terms, I will get this thing, equation number 2. Now you will consider this thing one by one. We have one thing here as x plus 1 and the other thing is x minus 1. First of all, I will let this thing is equals to 0, and then I will let this thing equals to 0 and use this in it to find the values of a, b and c, d. Let x minus 1 equals to 0, put x minus 1 in equation number 2. In this equation number 2, put x minus 1 equals to 0. This thing will be 0, this thing will be 0, this thing will also be 0. So I will get the value of d here out of it. Now let x plus 1 equals to 0 and put x is equals to minus 1 in equation number 2. I will get a equals to minus 1 over a. Now we are left with none of the function to let it equals to 0. But our sum of the constants are still unknown. Like I am able to calculate only a and d out of this two. But I need the value of b and c as well. So what I will do now? I will just use another method. I will just compare the coefficients of x cube, x square, x one by one out of this equation number 2. For that purpose, you need to just simplify this equation. It will be x square equals to a. Open this formula of x minus 1 whole cube. This will be, you know that if I open the formula of a minus b whole cube, it is a cube minus b cube minus 3ab, a minus b. So after opening this formula using this, I will get x cube minus 1. Now here I will have minus 3x into x minus 1. It will be minus 3x square plus 3x. Now multiply this as well. I will get x plus 1 into x square minus 2x plus 1. Then this thing x square minus 1 as it is, and plus d x plus 1 as it is. Now I can further multiply this b term. I can further multiply it. And I will get here b into x cube minus 2x square plus x square minus 2x and plus 1. This will be the coefficient of b. Now, comparing the coefficient of x cube in equation, let it equals to 3. In equation number 3, x cube coefficient. We don't have x cube on our left hand side. So there is no coefficient of x cube here. So I will write 0 here. Now, find the x cube. Here I have x cube. So what will be the coefficient of x cube here? A. Now, we don't have x cube here further. Move on. We have x cube here. So the coefficient of x cube is b. So I will write plus b. Now move further. I don't have coefficient of x cube here. I don't have basically x cube here. So there's no need to write some other coefficients. Now just put the value of a here. That is minus 1 over 8. And b will remain as it is. This will become b is equals to 1 by 8. Because this minus 1 by 8 will move other side. It will become plus 1 by 8. Now I got the value of b. Now I need the value of c. For that purpose, you see here. C has the function x square and the constant. So we can do two things here. We can compare the coefficient of x square or we can compare the constants as well. It's up to you what you are going to do. I am just comparing the coefficients of x square. Now on left hand side, I have the coefficient of x square 1. So I have written 1 here. I have the coefficients of x square here as minus 3a. So this is minus 3a like this. Then here I have the coefficient of x square as this minus 2x square plus x square will be minus x square and minus 1 into b is basically minus b. And here I have the coefficient of x square as c like this. And in d we don't have x square, so there's no need to write d here. Now just put the values that you know very well. After putting the values and simplifying, we will get c equals to 3 by 4 like this. Then using the values of a, b, c and d in equation number 1, I will get x square over x minus 1 whole cube x plus 1, a value, b value, c value and d value. Put these values like this and integrate both the sides. I will get this thing. Constants are taken outside like this. Now I can easily integrate them. Integration of 1 over x plus 1 is ln x plus 1. Integration of 1 over x minus 1 is ln x minus 1. Now x minus 1 whole square can be written as x minus 1 raised to power minus 2. And its integration will be power plus 1 and power plus 1 because it has its derivative with it. And same with the ending integration. Power plus 1 divided by power plus 1. After simplification, I will get this answer. This is the negative one, so I will make it positive by moving it in the denominator. Again here I will just make it the positive power by moving it into the denominator like this. I hope you understand till question number 5. For the rest of the questions, you need to wait for the exercise 4.4 part 2. Thank you.